Hi, I'm Greg Armstrong, one of the application engineers here at UEI. In this video, I'll demonstrate how to enable pull-up or pull-down resistors, also known as termination resistors, on UEI's multifunction boards. These resistors are part of the digital I/O subsystem and help define the default state of digital input lines. For this demo, I'll be using the multifunction board installed in one of our rectangle chassis. I've also connected the board to an external screw terminal panel and wired a mechanical button to one of the digital input lines. I've wired it so the input is normally floating, but when I press that button, it's connected to ground. I've also connected 24 volts to the input's DVCC. The whole system is connected to my PC, and I'll be using LabVIEW to configure and control the board. And instead of creating the LabVIEW VI from scratch, I'm going to use one of the free software samples we provide to our customers. This particular one is called Industrial Digital Input. For this demonstration, I'm going to modify the VI to enable termination resistors. Since those resistors are part of the digital output subsystem, the first thing we need to do is create a new digital output session. On the block diagram, I'll take the block that creates a digital input session, copy it, and change it to output. To enable the resistor on the board, I'll add a property node, connect it to the digital output session, and set the property to termination. Then I'll create a control for the termination property. And finally, I'll add a resource string to the session, rename it to digital output resource, and connect it to the session block. This is required to define which hardware resource the session is targeting. Now I'm going to switch to the front panel to arrange the controls I just added. I'm using the first digital input line in this demo, but can easily extend this setup to other lines by creating an array and controlling each line individually. I also need to change the digital output resource string from DI to DO to reflect the correct session type. Okay, back to the block diagram. After setting the termination property, I need to write the property to the board, and then start the output session. I'll configure the settings as needed. In this case, I'm not using the lines as outputs. We're simply enabling the termination resistors, so I can stop the session immediately after starting it. This ensures the configuration is applied without affecting the input behavior. To ensure proper execution order, I'm going to wire the error output from the termination setup into the start of the digital input session. This guarantees the termination configuration is applied before the input session begins. As I mentioned earlier, I've wired a button into the first digital input line. Currently, the termination is set to none, so none of the pull-up or pull-down resistors are enabled. Notice how the input state on the front panel doesn't change when I click Run to start the VI. And if I physically press the button connected to the board, still no change, because I haven't enabled the resistor yet. So, let's stop the session, change the termination setting to pull-up, and run it again. With the pull-up resistor enabled, the line defaults to a high state. And when we press the button, which connects the line to ground, the input state changes to low, confirming the pull-up resistor is functioning correctly. So there you have it. With just a few simple steps, you can enable and verify pull-up or pull-down resistors on UEI's multifunction boards using LabVIEW. By configuring the termination settings properly, you ensure reliable digital input behavior and avoid undefined states. Whether you're working with a single line or scaling to multiple inputs, This setup gives you full control over your digital inputs. Want to learn more? Visit our website for a deeper dive into the specs, features, and capabilities of our multifunction series of I/O solutions.